Okay, so I'm back from the shop, and I want to do a quick summary before I get back into this code. Shop summary, before I start looking at this. So, let's open up our utility pageant folder for a second. And, in the, I forgot where we put this. Oh yeah, shop summary, right? So a shop summary folder here. So I'm going to take this and copy this and say, shop summary folder. I'm going to put this into my notes so I can find this folder again. And so so this is like a month summary, right here. So we might want to do something like this. By month. I might want to do by day. Sure. And then we might want to take this thing here that's by day. Cut this, put it in here. Let's go back and let's put this month. Oh god. Close this. Let's open that up. So let's go find that shop summary folder again. And yeah, so this is like a monthly summary, right? It's cumulatively for the month and then by day. So we're going to go look at this monthly summary here for the current month we're in. And we're going to... so I just cut... as it was the 18th, I just cut 72 parts, well, 72 pieces. And if you take 72 pieces, like this is a measured and part to so there's a note here for a second. Table below measured in parts worth. For example, 1 bone equals 2 laser cut cross sections. Okay, yeah. So we need to make sure that, when we're looking at this, we have the tables kind of normalized here. And so we cut more 2As today. They were all black, and there were 72 of them. However, there were 72 cuts, but we have to pair those up to make single parts. So 72 divided by 2 would be 35 plus 1, 36, right? Let's check our math on a calculator. Yeah, 36. So yeah, the black parts is 36. Okay. And we might want to keep some type of running total here. Let's just say RT for running total. And right now, the running total is, we have 48. I don't think we need a running total. We should just keep a total. And if we need to subtract from the total, then we'll make it a running total, right? So right now, so in terms of the number of black pieces we need, in terms of two ways, okay, so I kept a... Okay, so we're going to say... We're going to remove this. We're going to remove this kind of thing here, because if we're going to make a total list here, if we're going to keep this as a table, this is redundant, right? Also, I realized that if these numbers eventually get in the triple digits, we're going to have some trouble here. Because there's no spacing here. Well, I mean... What are we going to do about that? I think the easiest way would be to make different tables for the different colors, right? That'd be the simplest way. They actually do like this consolidated list like this. This is a nice consolidated list. Like eventually we might end up in the hundreds, right? So this table might end up kind of going over our column limit, and maybe we'll just have to accept that, right? Maybe we just gotta accept that. So what do we want? So in terms of what we want, right, we want 112 here. And then we want 96 three-ways. We want 112, 112. Like, if we want, if we're trying to keep, if we're trying to make something, then we really just want, you know, 112 of everything, right? And then three-ways, we want, you know, we want 96. We want 96. 96 and 96. For the four-ways, we want 16, 16, and 16. So let's just make a little table here of what we want. And looking at how out of control this is going to get, I think we just need... I think we need three different inventory tables for the different colors. Because... So black two-ways. Black two-ways. Black three-ways. Black four-way. Black corner. And then black BA. What was BA? BA is for bats. Yeah, bat parts. If we do that, then we have a lot more room to, you know, keep a tallied. Like right, we have enough room where we can say, yeah, right now, in terms of black, we cut 12 on this day, right? We can keep it in the thousands. I think the thousands is fine. I think we could go over 999. I don't think we're gonna ever go over 1,000 though. So, right. So we don't have anything for these. Right. So we can just say, you know what? 1, 2, 3, 4. if we didn't cut any of a certain color on a certain day, okay. And 1, 2, 3, 4. Okay. And it looks like, well, this stamp needs to go over here, right? Because this was the day it was on. And then we can duplicate this and we say, oh, on this day we cut like 36, right? Since 12 we got 36 parts worth in terms of black, right? And I don't know what the order is. Black, blue, and then clear. So that's an interesting order, right? So no light, adding the blue wavelength, and then adding all other wavelengths, right, for clear. Or think of clear as white. That might be a way to think of it. So we don't have an arbitrary ordering. So, however, let's just call it K for black. Right, so K is, right, like CMYK. We already have B for black. So the idea is that you use K for black, right? It also makes it shorter. Though it does kind of wreck my usual variable naming scheme, but let's just keep it like this. Let's not worry too much about that. Okay, black, and then blues are just blues. We didn't cut anything, right? We haven't cut any blue so far for these days. And it's the 18th, and it's the 18th. And then for clear, so let's name this blue. So KBC. Okay, and then we'll take this, and we'll mark this as clear, right? So here's the clear. So, black. Okay, this is blue, and this is clear. So we got black, blue, and clear. Now as far as the clear, it looks like we had like 4 cut in terms of clear, 4 parts worth in clear. So let's make a note of that. That was on the first day, so 17, 18. So black, blue, and clear, we cut 4 worth. Okay. So do we want to keep a total? Just keep different totals over here, right? So the total right now is, 42, or 48, sorry, 48. And how many do we want if we're gonna make a total? So here's the total. And how much are we going to need to make a coffee table? The coffee table design. How many is that going to take? So the coffee table, 112, then 96, the 4 ways, we just need 16 of them, and the corners, 24, and then we need 16, right? So 2 of these things need 16. 24 for the corner. 96 for the 3-way. So we're just gonna keep the totals So these totals right here, there's nothing here yet. For over here, we have 4, right? Alright, so we have just 4. Because this is the clear. And then we're going to just remove this, right? We're going to remove this. And we're going to keep this as a little table. We might consider doing this in a programming-friendly way, like writing some JavaScript or something. But let's not get ahead of ourselves. Like, until we actually start pushing a lot of inventory, we really don't have to worry about that, right? See. So we're gonna keep a number of parts, right? Number of parts needed for your first product, which is a coffee table with 3x3 panels on the top. Okay. So let's put this in a section. So we have a shop summary. Let's just make a new thing called folder number of parts. Numpar. Call it cofftab._, right? So cofftab. And we'll make a list. We'll make something here. Number of parts in coffee table. I feel like I've asked this before, but now we have it in our shortcuts as well. So over here, I'm just making a note here that, you know, the number of parts in coffee table, or parts in coffee table, or parts in coffee table, spelling that actually correctly might help. Or cough tab parts, cough tab parts, cough tab parts, or cough tab parts, cough tab parts, cough tab parts. Right. Okay, so we're just going to do that so that we have a way to find this later, right? Because we're making these summaries of things. And we're going to have to start keeping like an inventory of the different parts. And it's going to start to take up a lot of room. Because if we decide we want to go and make designs with every single color, then the easiest thing to do would be have one box for every single type of part, right? So now we got, you know, 1, 2, 3, 4, 5 times, you know, 1, 2, 3. We got 15 boxes for all of the different parts we could possibly have. So since we already have started to we've already started to do one out of black, I'm thinking we try to keep it to right? It's going to slow us down if we try to cut all 3 colors, right? We're going to be 3 times as slow just to get the total number of parts if we're not careful. So we need to just keep our inventory to parts of 1 color, right? So it looks like black is already in the lead, so we should just start keep cutting the black, because otherwise we're just gonna have trouble on our hands if we try to cut all of these. So also, let's go look at shop summary folder by day. And if we didn't really do anything that memorable, we probably shouldn't make a summary, right? Because then the things that are important are probably going to be lost, right? So let's not, unless we want to do something like this. One, two, three. No, let's not do it. Let's not put a summary in here. If it was uneventful, then we don't want to put it in here, right? We just want to keep things down to like the by day thing. If we did something interesting on a certain day, then we'll keep it in there, right? But let's not put that here, right? If we need to know, because right now in our monthly month per month summary, right, we're keeping a month summary. We already have the aggregates of like how many parts we cut on a specific day, right? Because we have these days here. We're going to keep the day-by-day list for the whole month. So we don't need to be doing... we don't need to be... we don't need to be making other files for this. So let's just keep that as it is. And it's February 2021. So, So, February 2021 shop summary. So I'm just going to make a note of my shortcuts for that so I can find it. And yeah, I'm going to close this and say, you know what, we got this summary done. Let's just close this. We've kept track of what we did at the shop. And now we want to address the problems we're seeing over here. So, when I was looking at this code and trying to figure out what was going on with it, like what was wrong and trying to understand the code, I realized that, unfortunately, the best way to fix this code is to do a lot of floating point conversion. So this is the cluster size, right? So inside here is the cluster size. Here's the range of the source, the range of the destination. It gives us a cluster size, and then we take the input source value, right? We do some tile map math on the input source value based on the cluster size to figure out what the destination mapping is. I mean, it's a pretty simple... Well, I don't know if it's a simple formula. I mean, everything's simple when you understand it well, right? So yeah, this is what we want, but if we really want this to work out for ourselves, we need to be able to do... I don't know how well macros work here, but I'd like to keep it kind of easy. So right here and right here, we need floating point conversions. So we need a floating point conversion for this. And a floating point conversion for all that. And then if we're adding this, right, we don't want to mix float and... We can't mix float and not float, so... Add that all together. And that also means that we want to wrap this whole thing in a float conversion, right? So we want to like, actually, once we do this, we want to do make U32, right? So we want to take the result of all this and convert it back after we're done with it, right? So and so up here we might want to do something like this: define f as make f32, right? Make float 32, and then down here we'll just undef this. I don't know. Well, hopefully the preprocessor for GLSL kind of works just like C99, and we can do this, right? Because this is a macro that's going to point at this macro. Hopefully that doesn't lead to any type of problems. Also, we're on video 143, so let's change this. Okay. And we just have to manually go in here and do that. So, because I was looking at the math on some graph paper with this little example right over here. So this example on my right, is a very simplified example, one that I could kind of like actually look at with graph paper and understand the fundamental problem. And yeah, the problem that we're having right now is we gotta the flooring that comes from division when things don't go into themselves equally results in a larger output rather than a smaller output. And that's what we were seeing, right? Because division by a smaller number gets a larger number than we expected. So division by a smaller number than we expected outputs a larger number than we expected, right? That is the idea of what's kind of like happening here. And so we just want to kind of like go through here and fix that by just adding the float conversions here. Now this does get kind of ugly, and it might be like, well, you had a formula that worked really well for, this formula worked really well for when things didn't need to be perfect, this formula was working. Well, when things went into themselves evenly, this formula was working great. And it's something when things don't go into each other evenly. Or no, these kind of go into each other evenly, but the ranges don't, right? Yeah, the thing is that though I feel like this is making things uglier, the reality is we have to get the code correct first. Like, before we even worry about performance, we have to get the code correct, right? So that's what I think is the corrections that'll actually fix this. Now, the shader code might fail if we're not careful. The shader code might fail to compile if we're not careful. Like, it'll run as C99 code, but it might, like, fail over here. So let's just give it a shot. F redefined. So, somewhere F is redefined. So, oh, that's because, oh god, that was bad. Just make a note of this, right? So, sure. Okay, anyways. Just wondering why that... Yeah, I mean, if we're not good about cleaning up after ourselves, we're going to end up in a lot of trouble with, like, redefining macros. So far I've been pretty good at it, where I don't find myself in too much trouble, but then other times, I do. Test index is 10, and Okay, so first of all, we gotta make sure we know what function we're using. So we see we did this meta thing, and the meta thing may be using a different function than the one we just fixed, right? So if we look at the one we just fixed, this is called, damn it. Oh no, this is the one. So we're just gonna flip them around. Let's actually condense this, right? So we already know that 1, 2... Let's make sure these arguments are the same. And then let's just change the argument list here, right? So let's just take this, copy this, and paste it here, condense it. And let's just swap these around, right? So else, error, invalid, meta group picked 2021. Alright, so we'll keep that there, so now we can kind of easily grab this and just be like, boom! It's still technically correct, but now we can order it 1 and 2 like that. And right, this is the one we just fixed up, right? This is the one we just kind of added that floating point logic to, that we're kind of confident that works. And this one is not that case. So let's give that a shot and see if maybe we'll see MG2 here rather than, you know, MG1, right? So we're gonna run. We're hoping that the test that we just kind of rewrote kind of passes for all the test cases we've written. Okay. So we got up to 12, so that's better. Well, let's go look at 12, I guess. Let's go look at 12 and see what we can do here. So this is, boy oh boy, that's way off, right? So if we're lucky, when we're looking at the code, we just did the code wrong, right? If we're lucky, we did the code wrong, and the test is wrong, and so number 12, test number 12 up here. So 10, 11, and then 12 down here is failing us, huh? So 3 and 4, the lower range and the upper range for the output, right? Lower range and upper range. Lower range and upper range. Okay. And was that correct? Is that how we do this? Lower range and upper range, lower range and upper range. Yes, that is how we're doing it. And we're just getting some crazy, crazy stuff, aren't we? We're getting like 8 and 9. 8. We're getting like... We're still getting things kind of like way out there. We're expecting, you know, 5 and 6, and we're getting... We're getting remaps that are like way off. So... Now the question I have is, well... Uh, 444 to 333. So, 444 minus 333. That's 111. And then 666 minus 555. What's that? That's also 111, huh? Man. So, I mean, I'm fairly certain that's correct. With the math there. Do we have to... I don't know. Do we have to... We're still getting things where... it's just off by quite a lot. So we got the cluster size. The cluster size is the range of the source. So... let's just take this example here for a second. And... let's just work it out, I guess. So let's just say, you know... let's just have some time to, like, work this out. Let's actually create, like, a function where we're actually just going to work out the math. This is the set of values we want. And I don't know what's going on here. I don't know why it doesn't work. I don't know what's wrong with the math. So maybe we were just, maybe we can just go down here and, right, create a little function where we can throw this all together, right? So, let's just say, in 32 row 1, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 things in here. 4 and 4, that's 8, 9, 10, 11, 12. Yeah, there's 12 things in here. We're just going to call this row 1. And let's say, you know, SX in 32, SX equals, you know, row 1. 1, 2, so SX and SY, right? And then we have the lower bounds and upper bounds for the source. So source X, source, so the upper and lower bounds of what the inputs are, and then the destination bounds, and then the destination slash output dx. So this is what we're expecting, right? So this is what we're expecting. We're expecting dx dy, and then we just want to like throw in the numbers here. Okay, and we have the ability to kind of just steal what we have here, right? We can steal this formula and just try to get this formula working, right? So we can try to just work out the math here, like inline this math, and just use it to figure out what we're doing, right? And maybe along the way, we'll kind of figure out what's wrong with this specific case. Or we'll just be enraged and cry about it. I don't know. So this is making things harder to follow. Let's not do that. I mean, it is a little weird writing it kind of like way exploded like this, but that's the reality of what we're doing here. So so the make float 32 thing, let's just use this macro here and here. So let's just, you know, I don't know where we want to do this, so we could just say, you know, define and F is right, so make U32, make float 32. You can also undef these. Okay. And if dst.x is not equal to dx, or dst.y is not equal to dy, I'll just printf. Well, let's just do an error message. You've got some bad math. So we narrowed it down to a very specific case, and now we want to just make sure that for this very specific case, can we get the code to work for this very specific case? Like, what's going on for this case? Can we get the code to work just for this one specific case? So there's a specific formula for a specific case. That's kind of like the idea of what we're doing here. So let's just mark it as such. And I don't know what I'm doing. I'm trying to like just scratch out the work for this so that I have like a little proof of concept of like finally here's what I'm doing wrong in the math, right? That's what I'm hoping here. And yeah, so else printf, you've got some good math. Let's say year 2021 \n. Okay, yeah, let's give that a run. Yeah, and we're just trying to take this very specific case and see if we can emulate its failure and then figure out how to fix it, right? You've got some bad math. Excellent. So we got to think about, well, why do we have bad math, right? Like, what is wrong with this math? So first of all, we got x's and y's. Can we just concentrate on splitting this apart, right? So how we have this right here, like this. Can we separate this into x's and y's, right? So we're going to delete the second thing from all these, right? So okay, delete the second thing from here, and then we want to delete the first thing from here. Okay, so 333, 3344, 5566, 55. This one's 444. Right, so we have this 3 to 4 range, and one of them's the min, and the other one's the max, right? So we want to map the 3, 4 to 5, 6, and we're expecting if we use the lower, that we get the lower, and we're expecting that if we use the higher, that we get the higher out, right? That's the idea. So let's call this row 1, row 1. And I think it was the higher bound that was really messing with us. So let's just say, you know, row 1, row 2. And it was the upper bound that was failing us. So let's not even worry about this one, right? It's the upper bound that's failing us. So let's just take out the row number. And let's just look at the x's, right? So let's look at just the x's, take out the y's. Anything that has a y in it, we're just going to take it out, right, to distill this problem a little bit more. Okay. And the next thing we want to do is instead of xi, we want to change these to like, you know, x input, right? So remove this, right? We don't need that. We just want to isolate it on one thing. And then destination integer. So int32 destination integer. Or actually destination output. AKA, right, it could be DI for destination input, but that's kind of confusing. So DO makes more sense. And we could use DI over here, right? Since this is the input. There we go. And this SI thing, so we can just get rid of the numbers here, right? We can just go we can just get rid of the numbers, and then boom, we have the variables we're looking for, right? So we can just remove the x's in the middle. We have the minimum maximum for the source and the minimum maximum for the destination. And then down here. Okay, so we just want to isolate on one axis because we really only care about the mapping. It's going to be the same on the x-axis as it is the y-axis. We don't need that extra kind of confusion. DST is undeclared, so let's look at this. So dst.x. We want this to be do, right? So do equals this. Okay. Let's give it another shot and see if we can get it to fail. And then once we have it failing, we want to figure out, well, how can we... SI is undeclared, so... Oh, that's because this SX needs to be a SI. Don't know why I didn't fix that. And... it seems that at some point, when we were fixing this up, we introduced some type of horrible syntax error, and I don't know where I did it. We got the commas everywhere they go. The commas look good. The commas look good. 149, right? So 149 is way down here. This does look kind of sketchy, doesn't it? I don't even know why I wrote it like that. Okay. Okay, so we got some bad math. So let's just do some stuff here. So printf. Let's printf what these different equations are, right? So right, so let's take some of these equations that we have and just print off what the actual equations evaluate to, because I think that'll give us like an idea, give us a feel for why there's a failure, right? So, and then so this right here is number of chunks. Is this number of chunks or is this chunk size? Let's go look at our formula. We kind of we kept it pretty documented over here, didn't we? Cluster size. This is the cluster size. Or the chunk size would make sense. So we take the and for this cluster size, let's just take all this, right? Let's just take it all and just throw it inline it like this. I think we can do that. I think I can get away with that. And yeah. Okay. I'll be back. I gotta stop the stream because this is gonna take forever.